Okay, this video is going to cover solving one-step equations. Some of the problems are going to come from section 2.1 and some of them will come from section 2.2. Let's look at this first equation that I have here, x plus 2 equals 5. I think most everybody will be able to look at that and tell me that x is going to equal 3. So you can do that problem in your head. I really want you to be able to understand the process, not to be able to just look at a problem and tell me the answer. Let's look at a second example. You're probably not going to be able to solve this equation in your head easily. And even if you have a calculator is not going to help you solve an equation that looks like this. And we are going to be solving these types of equations in transition math, in intermediate algebra, and in college algebra. So you need to understand the process. You need to think of an equation is like a balance. What's on one side of the equation is equal to what's on the other side of the equation. They have the same value. So even though the two sides may not look alike, they do have the same value. So what happens when you take something off of one side of your balance, but you don't take it off the other side? Well, then it's not balanced anymore, so it's not equal anymore. So that's the same thing with an equation. If I'm going to take 2 off of this side of the equation, I also have to take 2 off of this side of the equation in order for it to stay balanced. Right? So this is one of the key things that you need to be sure that you understand with solving equations. What you do to one side of the equation, you have to do to the other. I see a lot of students solving this type of problem by doing this, and that's wrong. Right? You're not taking 2 away from just the right-hand side. You're taking 2 away from both sides of the equation. Okay, with problem 1 here, I have x minus 4 equals -1. We're going to use inverse operations to solve these equations. So I want to do the inverse of subtracting 4. So the inverse of subtracting 4 is adding 4. I add 4 to both sides of the equation. And over here on the left-hand side, if you want to, you can draw a line through that to show that those cancel. And that will leave you with x on the left-hand side. And on the right-hand side, we have -1 plus 4, and that's 3. Now, if you want to, you can also check this to be sure it works. Now, my original equation was x minus 4 equals -1. You don't really need to write that over again. I'm just going to write it again because I've got it crossed out over here. And I'm going to put 3 in place of that x, and I'm going to check to see, is this really a true statement? Are those two sides actually equal to each other? On the left-hand side, I have 3 minus 4, which is -1. On the right-hand side, I have -1. So that does check out. So my solution is x equals 3. Now, just to save time, I'm not going to go through and check all my answers, but you can do that on your homework and on your test. It's very useful to do that because it's telling you whether you got the right answer or not. Okay, problem 2, the operation that I have is plus 3. And the inverse of adding 3 is subtracting 3. So I'm going to subtract 3 from both sides of the equation, and I get -10 for my answer. Okay, problem 3. Notice that my variable is on the right-hand side. You need to be sure that you're used to having the variable on the right-hand side. If you look at this equation, what's being done to this x is that you're adding 6 to it. So in order to undo that, to figure out what x is, I have to undo adding 6, or the opposite of adding 6 is subtracting 6. So I subtract 6 from both sides of the equation, and I get x to equal -2. Okay. Problem 4, I want you to also understand that the x does not always come first. On problem 4, the x is what is being added. Now, if you're following the process like I've been doing the others, it's a little bit different here. I mean, the opposite of adding x is subtracting x. Well, I don't want to subtract x. I don't want to get rid of that. I want to get the x by itself, so I need to get rid of the 3. So I'm going to subtract 3 from both sides of the equation. So this will cancel, and I'm left with x on the left-hand side and negative 8 on the right-hand side. So x is negative 8. Okay, problem 5, I want to get this x by itself, so I need to get rid of this negative 6. So I want to do something to where that negative 6 will go away. Well, I could subtract the negative 6, but remember, subtracting a negative is the same thing as adding a positive. So the shortcut is just to add 6. I'm adding 6 to both sides of the equation. And if you look at just this part right here, you can see that those two numbers are opposites of each other, so they are going to cancel out. So sometimes it helps to just cover the rest of the problem up with your hand and just concentrate on what you're trying to cancel out. If those are opposites, they're going to cancel. So on the left-hand side, I just have x, and on the right-hand side, I have 18. And we can always go back and put 18 in place of x up here and check it, and it checks out. Now, problem 6, I'm trying to get the x by itself, so I need to get rid of the negative 7. So I'm going to add 7 to both sides of the equation. Right, so the 7's cancel, so x is going to equal to 5. Okay, these next 6 problems I would like for you to try on your own. So pause the video, do these, and then come back and check your answers. And there are your answers for 7 through 12. Okay, in this second half of the video, we're going to be looking at solving multiplication and division equations. So my numbering is starting over again. All right, problem 1, I have 3x equals 12. That means 3 times x equals 12. And I'm going to solve this problem by doing the inverse of multiplying by 3, which is dividing by 3. So I divide both sides of the equation by 3. Here on the left-hand side, they cancel, leaving me with just x. On the right-hand side, 12 divided by 3 gives me 4. Problem 2. It's very tempting to look at these numbers and say, oh, I know 2 times 2 is 4, but 2 is not the answer here. I'm dividing both sides of the equation by 4. Remember, I want to get the x by itself, so I need to get rid of the 4. So what I have here is x equals 2/4, which simplifies to 1/2. This is a common mistake that students make. They'll look at this and try and do it in their head and get the answer of 2 instead of 1/2. Now, problem 3, I'm going to divide both sides of the equation by 3. And on the left-hand side, the 3's are going to cancel, leaving me with just x. And on the right-hand side, there's nothing for me to do. I can't divide 3 into 7 evenly, so my answer is just 7/3. Okay, problem 4, I have a division problem, x divided by 6. The inverse of dividing by 6 is multiplying by 6. So I'm going to multiply both sides of the equation by 6. So on the left-hand side, they're going to cancel. On the right-hand side, I get negative 12. Okay, problem 5, I have x divided by negative 2. I want to get the x by itself, so I need to undo dividing by negative 2. And the way I do that is multiply by negative 2. This multiplication and division are inverses, so that cancels. So x is 14. Problem 6, I'm going to divide both sides of my equation by 7. And over here on the right-hand side, I have 0 divided by 7, and that is 0. Now, problem 7 and 8, I want us to look at kind of together. Both of these have a negative x, And I can write this as -1 times x, right, on both of these, and then divide both sides of my equation by -1. That's how you normally see this in textbooks. -20 divided by -1 is +20, and over here, when I divide by -1, I get x to equal -30. But I want us to look at these equations a little bit differently. Okay, my first equation, I have -x equals -20. Again, a better way to say this is probably the opposite of x equals -20. Well, if the opposite of x is -20, that means x has to be +20. And in my second equation, -x equals -30. Again, a better way to say that is the opposite of x is 30. So that means x has to be -30. So it doesn't really matter to me which way you do these problems, if you divide both sides by -1, or if you just reason through it by understanding the meaning of what that opposite or negative sign means. Okay, this next problem I'm going to do two different ways. And we're going to do the first problem out the long way, so hopefully to lay the basis of understanding the shortcut in the second method that we're going to use. Now remember that this is 2/3 times x, so if I follow this process the same way that I've been doing, the opposite of multiplying is dividing. So I would divide both sides of my equation by 2/3. And on the left-hand side, those fractions would cancel out, and I would just be left with x. Now on the right-hand side, I'm going to write this division problem differently. X divided by 2/3. Well, this goes back to what we learned in our very first lesson. When you divide fractions, you just flip the second fraction upside down and multiply. So now I have 6 times 2/3, right? 2 goes into 6 3 times. 3 times 3 is 9. So x equals 9. So that's a long ways to go to get that answer, and it looks kind of messy. Well, here's a shortcut. Notice that in the first method I used, when I divided by 2/3, I eventually had to take that fraction and flip it upside down and multiply. So we're just going to go straight to that process of flipping this fraction upside down and multiplying. So both sides of my equation gets multiplied by 3/2. Now on the left-hand side, what you have here when you multiply this out is 1 times x, which is just x. On the right-hand side, you end up with 9, so x equals 9. So either way you do the problem is okay, but we're going to use this method over here on the right-hand side. Take the reciprocal and multiply. Okay, problem 10, I'm going to multiply by the reciprocal. So the reciprocal of 1/3 is 3/1. And if you don't want to write 3/1, you don't have to, because 3/1 is just 3. So I could just write it like this, so I can easily multiply that out. So x is 18. Okay, these next 3 problems I would like for you to try on your own, so pause the video, see if you can do these, and then come back and check your answers. And there are your answers for 11 through 13. Now, I want to point something out about the second step here. I basically just rewrote the problem because I didn't want to get my original problem confused with what I was doing here. You don't need to rewrite this into 2 different steps. If you wanted to put this with the first step like I did on my previous problems, then that's fine. Okay, this last problem is going to put together a couple of different things here. Now the first fraction I have here is negative. I'm still going to be taking the reciprocal, so I'm just flipping this fraction upside down, it stays negative. So now I have negative 5/4. So multiply both sides of the equation by negative 5/4. If you want to put parentheses around that, you can. On the left-hand side, I get x, and on the right-hand side, I have a negative times a negative, which is positive. And you say 4 goes into 25 times 5 is 25.